Welcome to another session from the Green World Group, and today's topic is about firefighting. So, before we talk about firefighting, we must understand what fire really is, right? So, yes, you can Google fire and figure out what that is, or you could come up with the conclusion that what we've been seeing throughout our lives. Well, let's talk about mainly what fire is. We use fire a lot. We use it for many things, and we mold things with it. We manufacture things with it. We also use fire to cook, right? It's in our daily use. Smoker uses a lighter to light a cigarette with fire. But what fire really is, right? That's the major question. If we can understand that, we can manipulate it and use it and either extinguish it as well and fight it, so to say. But you must ask that question to yourself. What is fire? Think of you explaining to a child what fire is, because a child would be very inquisitive. But if you just tell the child that fire is just going to burn you, you would probably create a phobia in the child while he grows up, and he will always be scared of. But it is very important to make sure that we have an understanding of what fire is. So, under Google's translations, yes, fire is the rapid oxidization of materials in the extrathermal chemical process of combustion, releasing heat, light, and various products. Some people understand that and try to simplify that, but let's try simplifying that in much more simpler ways. So let's say if we have light, concentrated light, in a place, we can create heat from that. If that concentration keeps constant and increases also over time, we can create heat, and from which we can create smoke. And then from that, we'll create fire, right? The burning stage, so to say. But we need to also realize that fire is the leading cause of major injuries, as well as fatalities, and not to mention property damage. In this day and age, fire could be caused by many things that we will talk about in more detail. But if we look at the statistics of fire itself, a lot of civilians do get entrapped and engulfed in fire from burning buildings, as well as there is a huge amount of property damage. Now, if facilities and buildings catch on fire, they become inhabitable, right? And it's a lot of cost to repair, and obviously you're losing production, you're losing office time, you're losing time that you could have used to generate money, right? So moving forward, there are three elements, or there are three things that create the fire. If we can understand the triangle of fire, then we can use it to our advantage and manipulate it to either do what we need to do with it, or we can extinguish it or fight it, right? So what are the three things that make fire? We have oxygen, we have heat, and we have fuel, right? So what the fire can eat. These three combined, and now recent studies have said that to combine these three, there must be also the fourth factor, which is the chain reaction that connects all three of these together, right? So understanding the fire pyramid, or the fire triangle, so to say, is the most essential part. What are the three things that would create fire? So if we have fuel, fuel is whatever the fire can eat, right? It could be any solid, could be liquid, could be gas, or it could be electric, whatever's fueling the fire, right? Then we have the oxygen that's practically all around us. Right? Now, the increase of oxygen obviously will increase the flow of the fire. Then we have the heat. The heat would be the ignition source in most terms. That spark, that initiation, it could be something as small as static electricity, right? That could create this. So we've come a long way from where we used to create fire from beyond, let's say, in the 1920s. I mean, in the 1920s, we created lighters, and then a year later, we created a match. But before that, we were creating fire the camping style way, where we would dig a hole, gather dry wood bark, set them up, fine to rocks that would create friction or create spark from that, and make sure that it lands into the bark or the dry branches. And then from that, we would only create smoke. So we would apply oxygen or increase the flow of air there, and then it would ignite the fire, right? And then to keep it going, we'd keep adding wood. So from that, we've come towards something that is pocket-sized for, say, a lighter or a match, which was just recently created, I would say recently, but in the 1920s. And a year later, the match came out. So understanding these three things, oxygen, fuel, and the heat source, is very essential, because if we can eliminate any one of these, then we can fight the fire that is in front of us. So the terminology with that goes with, so if we remove the heat, we are cooling the fire. If we remove the fuel, we are starving the fire, because there's nothing the fire can eat. Then if we remove the oxygen, we are smothering it, right? Now, in this day and age, the most common source of heat sources are electrical, because we have electricity we are generating electricity for our daily use, and we're using it in terms of there are wires, there are plugs, there are sockets, there are generators, there are circuit boards, power panels, right? So these would they amplify the effects or the damages that will come from it. We will discuss about exactly what extinguishers we would require to fight these fires, right? But we must inspect these electrical sources or these sources of these ignitions so that we don't have problems or we don't have to fight fire on a great magnitude, because the damage could be very severe, right? There are obviously constant friction, grinding of similar objects could create ignition sources, could create heat, obviously, which generates heat from friction and would create fire. So as I mentioned before, the hitting of two rocks creating spark, that's friction, right? We rub our hands together constantly, we generate heat, right? If we keep going, maybe we might ignite, but it wouldn't happen that way, because we would stop as quickly as possible, because of it being as warm as we could. So cutting, welding, these are industrial sources of ignition where we would require the heat source to either modify or mold or even fabricate things that we would need in the industry, which would require a hot work permit to conduct the job. So again, these heat sources that I want to explain a little more. So we have the match, we have a candle, and we have a lighter. I've explained to you what the lighter is, but let's look at the three elements that are in the lighter. So we have the butane, which is the fuel for that light. We have now two types of lighters nowadays. We have the electrical one, the click, that just emits a spark. And then we have the friction one, which actually has the rock that you rub against. It will create that spark, and the butane and the oxygen around it does the job for you to keep that lighter going. Then let's talk about matches. Matches. The fuel source for the match is the wood that how big the wood is or how long the wood is, the fire will keep continuing. But where's the heat? Where's the ignition? The ignition is the sulfurous, which is also on the match, which you would use it as friction to ignite, right? And if we increase the oxygen on that, we can eliminate the fire as well because of the fuel source being so little. But what about the candle? Candle's the only thing that would require direct fire to ignite, right? Either a lighter or a match. So where's the fuel for the lighter? The candle. Here, a lot of people would say, oh, the wax, but really it's the wick. The wick is the fuel source. The the wax itself is actually a dampener. It slows down the process of the wick burning too fast, for which candles can ignite for a long period of time, right? Here's an interesting thing. Ever light a candle and then blow it away and watch the smoke trail. Now, all you need to do is take a lighter and try igniting the smoke, and you would see the smoke, the flame following the smoke all the way to the wick. That is not a magic trick. That is actually a simple explanation, which I've been explaining all this time, is that the lower stage of fire is smoke. So the next stage to smoke, which is fire, right? And the stage lower to fire is smoke. So that's just a little less hotter, and the smoke can ignite through, and it can travel all the way to its fuel source that it can light up to. Remembering that and understanding that could save a lot of lives and help you out in a lot of things in this life. Now, going into classifications of fire, because water is not the solution for everything. So we can't just throw water on every type of fire we can find or any source of fire, but we must understand what class of fire it is, because we're talking about elements that will catch on fire or sources. So now, obviously, there are two standards in this world. There's the European British standard, and then there's the American standard. Just a slight variation. I wouldn't go into the British standard. Again, if you are interested, please join us for a full course with Greenworld. But what I will talk to you about is the American standard, which is also known as the simpler standard. But here, so we have 5 classes of fire. We've differentiated between 5 different classes. We have class A, the ordinary fire. We have class B, gases, fuels, petrol, diesel, solvents. And then we have class C, which is the electrical source fire, any fire that is caused from electricity. And then we have class D, any metallic fires like sodium, magnesium, aluminum. And then lastly, which was recently developed in the 1995, I believe, or in the late 95s, is cooking. Cooking what? Cooking oil fire. So fire that can be generated off of oil, cooking oil, or fat. Right. So that's class K. K for kitchen. All right. Let's go in more detail into these. So we have class A. Class A is very ordinary fire that can be eliminated or extinguished from water. Right. So what are those? Those are wood, cloth, plastics, paper, right? Then we have class B fire. Class B fire is petrol, diesel, oil, paints, solvents, anything, any product that has the flammable logo on it. I wouldn't say any product, but yes, in this category, right? Then we have class C fire, which is electrical. We've discussed this a little more, but yeah, any electrical source fire, which would be power panels, which would be battery oriented, which would be electrical sockets, or even any electrical appliances that will catch on fire. Then we have class D fire. Now, Class D fire is metallic fire that would ignite or could also have a lot of combustion around it because of its magnitude of fire, because it uses metallic. So it's titanium, potassium, sodium. Now, simple thing with metallic fires is that the flame emitted from these are always of a very different color. So it's easier to distinguish that. And you should identify the flame color as quickly as possible in case of emergencies to understand what type of proper extinguisher you would use, right? Then comes the Class K. Class K is the cooking oil and fat fire, which obviously if we put oil on the stove to fry something, there's a point where we can use it to do the cooking. But then if we leave it for too long, it has a flash point, which will ignite. So one of the most best ways to deal with that, if it's immediate, is to smother the fire as quickly as possible by either putting the lid on it or putting a damp cloth over it. But never apply water directly into the burning oil. Why? Because obviously it will throw particles all over the place. There will be debris, right? But there's a very special extinguishers that we've created for just this class itself. So let's talk about the extinguishers. What do we need to fight? Well, Class A, water extinguishers. We have foam extinguishers, we have dry powder extinguishers, we have carbon dioxide extinguishers, CO2, and then we have the wet chemical extinguishers. I'm only going to talk about 3 major extinguishers here because of the limitation of time. Dry powder is one of the most common extinguishers that companies and you would see mostly all around. People within companies and organizations would invest in. Why? Because it covers most of the classes. But what you must understand are the 2 major disadvantages with dry powder. First, you lose visibility. Second, you'll have breathing problems because it's powder. Now, the second one I want to talk to you about is carbon dioxide. Carbon dioxide is CO2. This is a great extinguisher for electrical fires. But there's also one thing that you must understand, that in order to use a CO2 extinguisher, you must be wearing gloves. Why so? Because you can end up with frostbites. The container could get very cold because of it emitting carbon dioxide. Then the last one, wet chemical. This is the extinguisher for Class K fires. Class K fires should be should be extinguished using a wet chemical extinguisher. Now, every fire that you tackle, first of all, every extinguisher is only a one-time use. So be careful with the way you use your extinguisher. Extinguish the fire with your extinguisher, but stop when you have extinguished the fire, but then wait, because what you've only done is you've cooled off the top surface. You still have to cool off the bottom surface, because what's going to happen is the heat from the bottom is going to travel up, and once it gets oxidized, it will catch on fire. It will reignite. So we must be careful in how we use our extinguishers. We should be thoughtful in terms of using the extinguisher, that we can save a little, that if this fire comes back, which should be in probably 5 to 6 minutes, then we try to re-extinguish it and try cooling off the bottom part so that it also cools off and you wouldn't have that problem again. Now, extinguishers are element-based, meaning we are supposed to use extinguishers for the classes of fires that we have, but extinguishers should never be used on another human being. So if a human being catches on fire, what should he do or she do? Well, always remember, never run and never panic. This is the one safety rule that we would always keep telling you, to never run, never panic. Why? Because it will create more obstacles. But here, if you're ignited and if you're engulfed in fire, if you run, you oxidize yourself a lot more, which means you increase the flow of oxygen and you would catch on fire much faster and it would be much harder to control. So what you should do is stop, drop, and roll, right? And if an individual is doing that while he's on fire, the other individual who sees this should immediately run and find him a fire blanket and try to cover him up to extinguish, to smother the fire as quickly as possible, right? So with that said, thank you very much. My name is Vasir Shwak Ahmed. I am here on behalf of Green World Group, and we would love to see you guys in the next session. Thank you very much. Signing off.